In this video, we're going to focus in on one particular topic that uses chain rule. And this is a very common rule that we see, so we actually give it its own special name. So this is just chain rule, but it's chain rule where you're applying it to the extended power rule. So basically, it's this chain rule where you're dealing with the power rule. That's all it is. So if you look at this little definition at the top here, the derivative with respect to x of u to the n. So remember, we use u to represent a function of x, so u of x. This is something involving x. And then n is the power on that. So you have a power on a function of x. You can see example here in the first problem. So inside we have a function, u of x, and then we have a power on the whole thing. When you have the situation, you're going to use the power rule on the derivative of the outside. Remember, power rule is on the outside here. So power rule says we bring the power down, we do one power less. The inside stays the same. That's the chain rule part. Then the end of the chain rule says after you finish the power rule, you take the derivative of the inside and you multiply by it. So let's try and apply it to this problem here. So we see that we have a function inside, and we have a power on that. The outside is the power. So we're going to take the derivative of the outside, which means you're going to apply the power rule. So the power comes down. We keep the inside the same. Don't forget to finish your power rule. You need your new power. This is something that a lot of students forget, is to write that new power there. So make sure you finish the power rule. Power came down, one power less, inside is the same. Times, I could write d dx of the inside, or I can just write the derivative. I'm going to write the derivative because I've done a bunch where I did d dx. All right, so what is the derivative of the inside? So here's my inside. I need the derivative. What rules are you going to use? In this case, it's just power rule. Power comes down, so 15x squared minus power comes down, 4x cubed. That's it. You're done. If you want to factor out the x squared, you could, but this would be perfectly acceptable to me. All right, let's look at this one. So you might notice here that this one doesn't actually have a power. It's actually a fraction. But remember, when we're doing derivatives, there's usually more than one way to approach it. Like on the last problem, we could have FOILed that out 7 times, but that's not reasonable. So the power rule is a better way to go. On this one, the way it's written right now, what rule would you need to use? You should see quotient rule. That's what you need to use right now. But we can use algebra to rewrite this in such a way that we can maybe use the extended power rule. So can you think about it? How would you rewrite this to be able to use the extended power rule? So d dx of the inside, the denominator, bring it up into the numerator, and then it has a power of what? -1. Now you can use the extended power rule. All right, so how does extended power rule work? Power comes down in front, so our -1 goes in front. You could put the 1 or just the negative. The inside stays the same. Don't forget your new power, -2. After you've done the power rule, you then have to finish the chain rule. Do the derivative of the inside. So d dx, do the derivative. What's the derivative of 3x minus 2? Well, the -2 is 0. That goes away. The derivative of 3x, that's a 3. All right. If I were you, I would simplify a little bit by putting the 3 and the -1 together. The parentheses is kind of up to you. You can leave it in the numerator with a negative, or you could bring it down to the bottom and write it with a positive exponent. Either way you want. So this would be the answer for that derivative. All right, let's see what else we got. All right, ooh, this is exciting. It's a trig. So this is actually something that some students might not remember. When you have sine to the 5th power, that doesn't mean sine to the 5th power and then x. This means sine of x to the 5th power. Remember, a power on sine or any trig function is actually a power on the whole thing. So this is really what we're taking the derivative of. So what rule do you need? Well, on the outside, you have a power. So the extended power rule is the one that you would want to apply here. The derivative of the power, the outside function, power comes down. Inside stays the same. What's your new power? 4. times, now we need the derivative of the inside. What's the derivative of sine? Cosine. And there you go. If you want, you can rewrite it. I like to put the, in basically ascending order, I guess. So I like to put the cosine first, and then sine. You can leave the parentheses with the 4 on the outside, or you can bring the 4 back inside the way the original was written. There you go. That's it. That's the derivative. Let's do a couple more. Okay, so here we have another problem, d dx of e. Now, this might be a little tricky here. Who's the outside function? The e. But inside of e, we have a crazy mess. So let's think about how we're going to do the derivative of the inside. Well, I don't know how to deal with square roots. So first step would actually be to get rid of the square root. Do you know how to rewrite a square root? I'm going to make that e big so we remember he's the base. 3x plus 2, instead of the square root, we can write the 1/2 power. So let's get started here. We're going to use a chain rule because this is not a power rule. The outside function is actually the e. All of this is your inside. So when we take the derivative, we take the derivative of e. What's the derivative of e? That's just itself. So e stays e. The inside stays the same. It does not change. If you want to put the root back, you can. Times, now we need the derivative of the inside. Oh, wait a second. How do we take the derivative of the inside? Well, that's the extended power rule, or the power chain rule. Because you have a power, and inside the power you have a function. So basically, this is a double chain rule. You have e, then you have a power, and then you have the inside. So there's 3 different functions going on here. All right, according to the extended power rule says we bring the power down. So the 1/2 comes down, the inside stays the same, and our new power is -1 from that. So 1/2 minus 1 will be -1/2. But you're not done because there's an inside of this one that you just did. Finish your extended power rule. You got to take the derivative of the inside. So what's the derivative of 3x plus 2? 3. So to finish this off, my preference, this is technically right, the 1/2 and the 3, you should at very least put those together. But I would write this as a fraction, I think. I don't know. Yeah, it'd be prettier as a fraction. All right, so the 3 is on top and the e is on top. I'm gonna put the square root back. You don't have to, but I like to make it more uniform like the original. And then the 2 is on the bottom. And I'm gonna take this parenthesis with a negative exponent, and I'm gonna bring him to the bottom. When I bring him to the bottom, he's gonna have a positive 1/2 exponent, which means the square root of this guy here. And there you have it. Okay? So that's one way to rewrite it. Or you just leave it as is, put the 3/2 in the front. All right, we got another one right here. Oh, I think this is our last one. Yeah. All right, so taking the derivative. First of all, what do we do with this number in front? Well, he's a constant multiple, so he's just going to chill out. So we're going to do dr d theta. We're going to leave the 6 alone. He's going to multiply by whatever we end up with. What about the rest of this? If you look at the rest of this, what is the outside function? You should see the 3/2 as being the outside function. So this is the extended power rule. So we need to bring the extended power rule here. So what does it say we do? Power down. Inside stays the same. And we subtract 1 from the power. So that'd be 3/2 minus 2/2. So this would be 1/2. Times, remember you're not done yet. This is the extended power rule. You've only done the power part. You still need to do the derivative of the inside. What was the derivative of secant? Secant tangent minus, what was the derivative of tangent? That's secant squared. Okay. Now this we can simplify a little bit. So the 6 and the 2 can reduce. So that'd be 3 and 1. Or 9. 3 times 3. And then let's see. Over in this section, we have something in common. So we can actually factor out secant of theta, which would leave us with tangent of theta minus secant of theta. that is so close to being what's in the first set of parentheses. It's just the wrong sign. So we can fix that by pulling out a negative. So pull out a negative secant, and then these two we're going to just change signs. So I'm going to change the order so it matches the other parenthesis. So we have a power of 1. All right, so we pulled out a negative and a secant, and then we're going to put all of this together with this one. Because they're the same, we just add the powers. So secant of theta minus tangent of theta to the 1/2 and 1 make 3/2. And there you go. That would be your derivative. So lots of examples. Chain rule really requires a lot of practice. If you prefer to use the u and v note, or the u and the du, dv, du, dx, dy, du, that notation, you go for it. I find the process works better for most students, but you do what is best for you. Let me know if I can help you. I'll see you in the next video.